We're slicing it. All right, good morning. Welcome back. I hope you guys are all doing well, staying safe. Happy Cinco de Mayo as well. Looking for a few people for today's class. Looking for Fatuma B, looking for Edvin, Matthew, Maya, Fatuma S, and Gianna. If you're here, please let me know. Again, Fatuma, Edvin, Matthew, Amaya, Fatuma, and Gianna. If you're here, let me know, please. All right, let's get rolling. Let's figure out what's happened for the best class of the day. So before we do that, let's check out the COVID update, see where the numbers lie in Oneida County. Right now, in Oneida County, those numbers decreased quite a bit. I think there was 385 yesterday. Today, there's 338 active cases, 338 active cases of COVID in the county. Resolved cases, 20,850 resolved cases, and total deaths. We added a couple more deaths in the last couple of days from COVID complications. 420 people passed away from COVID complications. Check out the number of people in the hospital. 13 people in the hospital, 4 people in ICU. Still a lot of people in ICU. Vaccine numbers are increasing slowly. Once we get to about 60, 70% for herd immunity, then these numbers will really start to really decrease. The number of cases per day will continue to decrease, hopefully till it's gone. Hi, Fatuma. Please try to get here a couple minutes earlier. All right, number of daily positive numbers, number of daily positive cases. Here we go. Let's check out this curve. Zoomed out, it looks like we're heading in the right direction again. Hopefully we are. So things are really starting to open up now. May 18th, more and more things are opening up. The Stanley, they're saying, could have full capacity if people are vaccinated or some other guideline there. Vaccinated or one other, I don't know exactly. But things are definitely starting to open up in the area. Last few days worth of data, we're definitely heading in the right direction. Let's see what those numbers are. So Cuomo is definitely opening things up. Restaurants could go in full capacity. Movie theaters are going to be opening up a lot fuller. Last few days worth of data. Here we go. Check it out. On the 3rd, we had 16 cases. Awesome. 16 cases. 2nd, we had 19. We had 23 on the 1st. Day before that, 41. Day before that, 35. Day before that, 48. So you could definitely analyze this data and say, oh, looks like good last 6 days worth of data. Hopefully we stay down here. Hopefully stay on that range. That's the COVID report for today. Reminder, COVID's definitely in the county. Be smart, be safe, protect yourself, protect your loved ones. Another piece of news, I think they opened up the Pfizer vaccine to people that are individuals that are 12 to 15. That's cool. If you're 12 to 15 years old, then they're going to start opening up the vaccines for the Pfizer. But one little note, just because you get vaccinated does not mean you are totally free from getting COVID. There are cases out in the country that people that are fully vaccinated that got COVID. So still be smart, be safe. All right, there's a COVID report for today. Next up on the plate, here we go. Happy Cinco de Mayo. Welcome back Wednesday. The quote of the week comes from an unknown source. Chemistry states, the more energy put into a bond, the harder it is to break. I have been putting energy into this class. Hopefully you feel it. I'm putting energy into this class. We're building this bond together. Next year when I see you in the hallway, hopefully you say hi to me. Hey, Mr. Brown. Because our bond that we are creating now in class that you see me every day on the Chromebook, the computer, that bond's going to be tough to break. So we're in chemistry together, guys. Hopefully you're learning some stuff. Thank you. All right, today's Wednesday, May 5th, 2021. It's a day 2. We are finishing up Unit 9, acid, bases, and salts. We're going through topic 5B, which is titration today. We'll go through a couple of YouTube flicks. We have some notes, more flicks, and then examples. We will not do the extra pass today. We'll save that for another day. But anyways, titration. What is titration? You're mixing an acid, you're mixing a base, you're mixing a 1 pH, you're mixing mixing a 14 pH. You're neutralizing it like a 7, and your products are going to be salt and water. So we're taking acid and bases, topic 1, topic 2, topic 3. We're mixing them together to neutralize them to make salt and water. And this is going to be done with an apparatus called a burette. So this thing over here, I'm not going to do the demonstration in class. You have an Erlenmeyer flask. There's my Erlenmeyer flask. This thing's called a burette. It's a really narrow graduated cylinder. And if you look at the top, there's a little funnel on top. Whoop. Funnel on top. And then on this little burette, there's some fine grid lines. It's a very accurate tool for measuring a volume. On this burette, what's going to happen, you're going to put a acid or base inside the cylinder, and then you're going to take this, it's called a stopcock. I know, real funny, stopcock. This rotates 90 degrees. It opens it, and it closes the burette. What's going to happen, there's going to be some sort of solution on the bottom. There's going to be some sort of indicator on the bottom, probably phenolphthalein. And what's going to happen, it's going to turn pink. We're going to try to figure out when in the volume where it turns pink. And then we'll calculate what the concentration is going to be. Probably don't know much from that right there, but let's figure out what titration is throughout the duration of today's class. Let's start for the video. Might be like a little web quest today. And titration. Let me refresh this screen. All right, so take a minute to read the 3 sentences or whatever it takes to read it. So please read through that. We'll figure out the first video on titration. All right, let's watch this flick.
Breaking news. There has been an accident involving a lorry carrying over 1,000 litres of hydrochloric acid. It is feared that some of the acid might have leaked into a nearby river upstream of a site of special scientific interest. Chemists are at the scene to assess the damage and work out how acidic the river has become. When an acid, for example hydrochloric acid, is mixed with water, it completely dissociates, producing a solution of hydrogen ions and chloride ions. Acids can be neutralized by substances called bases. Bases that are soluble in water are called alkalis. When an alkali, such as sodium hydroxide, is dissolved in water, it completely dissociates, so that all of the sodium ions and hydroxide ions are dispersed randomly in the solution. An acid and alkali react to form a salt and water. For example, sodium hydroxide and hydrochloric acid react to form sodium chloride and water. If we draw the dissolved compounds as ions, we can simplify the equation leaving out the sodium ions and the chloride ions. They are known as spectator ions because they appear on both sides of the equation. When we have removed all the spectator ions, we are left with the net ionic equation, showing just the hydrogen ion and the hydroxide ion reacting to form a molecule of water. A concentration of a solution tells us the amount of a substance dissolved in a volume. It is measured in moles per cubic decimeter. We can determine the concentration of hydrogen ions in an acid solution by performing a titration experiment. As the acid is added to the alkali, the hydrogen ions react with hydroxide ions to form molecules of water. The end of the titration is when all of the alkali has reacted. At this point, the pH is neutral. We use an indicator compound which changes color when the point of neutralization is reached. In this example, the balanced equation shows that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. The amount of alkali can be calculated using the known concentration and volume of the alkali solution. The volume of acid that reacted can be read from the burette. It's good practice to repeat the titration and calculate the average volume added. We can now rearrange the equation to calculate the unknown concentration of acid. As part of the environmental response team, You will have to act quickly to assess the environmental impact of the acid spill and advise on an appropriate response to protect the site of special scientific interest. Samples from the contaminated river have been collected and transported back to the laboratory ready for you to test. In this activity, you will learn how to set up and run a titration experiment to calculate the unknown concentrations of acid in the samples collected from the contaminated river. You'll need to carefully add just the right amount of acid to the alkali solution to reach the neutralization point and judge when the indicator color changes.
All right, so a titration example, titration apparatus is going to have a stand, it's going to have an Erlenmeyer flask, it's going to have an acid, it's going to have a base, it's going to have a burette as well. So let's take some notes on acid bases. We won't do this activity right now, but maybe next time we'll do this activity. We'll figure out how to neutralize that solution. So please open up your guided notes. This will be the last day of new notes for the unit. That means your unit packet of guided notes will be due this Saturday. So if there's anything you're missing, please make sure you have it completed, turned in by Saturday. So that means upload your pictures, finalize whatever you need to finalize, whatever you need to do. So this unit, we went through acid, bases, and salts. We talked about Arrhenius acids for topic 1. Topic 2, we went through Bronsted-Lowry theory. Topic 3, we went through Lewis. We went through pH scale. We talked about indicators. We talked about neutralization last time, and today we're going to wrap up and finish up titration. So let's scan through this really quick. Some of you guys have to finish up your notes, so you might want to watch the recorded lesson to finalize your notes. We should know that acids are going to be acidic, they're tart, they're sour taste. We should know what this means. Change the color of an acid-base indicator. The strip, they change the color of that. They could be strong or weak. Bases are going to taste bitter, they're hazardous. Soap's a base, they feel slippery. They change the color of a acid-base indicator, they're strong or weak. So very vague definition for base. We know what that means now. We said Arrhenius acids are going to be H plus or hydronium ions. Bases are going to be hydroxide or OH negative ions. We looked at common acids. We said every common acid on the reference table has an H plus ion, H plus, H plus, H plus. These are all represented on the reference table or in the reference table. We talked about mono, di, and triprotic acids, 1, 2, and 3 different ions that can be separated. We didn't really care about that too much, but we introduced it. We talked about a chemical equation with Arrhenius acids. We talked about Arrhenius bases, meaning OH negative. There's an equation. We looked at common bases, OH negative, OH negative, OH negative, hydroxide, 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 and we should be aware that ammonia is a base. There's the bare basics for Arrhenius acids and bases. We looked at Bronsted-Lowry acid and bases. Bronsted-Lowry, an acid is going to be an H plus or proton donor. A base is an H plus or proton acceptor. When we analyzed in the chemical equation, we figured out which two are paired up together. NH3 is most similar with NH4. We said water is most similar to OH. Those would be paired up together. We figured out which one's donating, which one's accepting an H or proton. We looked at conjugate acid, conjugate bases. We looked at pairs. We figured out these two are pairs. 2 blue rectangles are squares. 2 ovals are going to be a pair as well. Then we talked about conjugate acid bases. We talked about Lewis, but we didn't really care about Lewis and the electrons donated or accepted. There was no exit pass on this. This will not be on the exit passes. It will not be on the benchmark exam, nor will it be on the post test. There's a little key for us for Arrhenius and Bronsted. We looked at the activity series in comparison with acids. We said every metal above H2 is reacting with an acid. All these metals above react with the acid. The metals below do not react with the acid. I know it's a small image there. So copper, silver, gold do not react with acids. That's why they have their luster. We talked about indicators. Last class, we did a demonstration on indicators. We analyzed several questions on that. We spent a whole class talking about pHs, the pH scale. We should know what makes an acid and acid, we should know what makes a base a base. Acid is going to have H plus. The base is going to have OH negative. So you should know about acids and bases. You should know what makes a strong acid. What makes a weak acid? What makes something neutral? What makes something a weak base and what makes something a strong base? Spend a lot of time talking about that pH scale and drawing it. That will definitely be worth a lot of points when I check out the notes. Make sure that's in there. We talked about neutralization last class. We said neutralization's an acid plus a base yields to make salt in water. Neutralization reaction we did. And now we're talking about this burette in Erlenmeyer flask in titration. I'm just going to label this topic 5B. Topic 5B. So this is where we left off in the notes, titration. It's going to feel like a math class today. You will need a calculator if you have one, or you can use the app. I know there's a nice app on the phones, Calculate 84. Maybe you want to download that. I don't know if you have to buy that one or not. All right, so topic 5B is titration. What's going to happen here? There's going to be some math equations that we'll have to analyze. So titration is a process of adding measured volumes of an acid or base of a known concentration to an acid or base of an unknown concentration until neutralization occurs. So again, I'm going to highlight, I'm going to bold, I'm going to cap lock, and titration is a process of adding measured volumes of an acid or a base. So we have to have a measured volume of an acid or a measured volume of a base. So we have to have a known volume. So precision and accuracy of measurements is key here. Of a known concentration to an acid or a base of an unknown concentration until neutralization occurs. So until neutralization occurs. So this unit should have been a relatively easy unit if you understood the basics of each topic. We know what makes an acid an acid. An acid is going to be H plus or hydronium. A base is going to be OH negative or hydroxide. So this unit builds on top of each other. We took the acids concepts, we took the base concepts, we talked about the pH scale, we talked about neutralization, we talked about indicators. Now we're taking an acid, we're taking a base, we're mixing them together to neutralize them with a laboratory experiment. We're going to figure out concentrations here. So titration is a process of adding measured volumes, that's going to go in the burette, of an acid or a base to a known concentration. So concentration is going to be the number out front of the compound. Scrolling down, looks like we're good here. It's good, I can actually gauge whether or not I'm going too fast. The known concentration. So here's the apparatus I showed you in the beginning of the class. The known concentration is considered the standard. Known concentration is called the standard solution. Well, the sun's gonna be out tomorrow at least. Another rainy day today, sun tomorrow. How was spring break like 80 degrees and now we haven't really seen 80 degrees since? Crazy. All right, you're welcome. All right, the known concentration is called the standard solution. So there will be something that's going to give you a known concentration. And knowing the volumes of the acid and base are key. Know the volumes of the acid and the base used for the titration, together with the known concentration. So you should see concentration. You should see volume a lot here. You should see acid. You should see base. These are going to be used for calculating the unknown solution. It is possible to calculate the concentration of the unknown solution. And we'll do that. We'll practice that. We'll figure out how to do that. Let's watch a quick flick. Titration.
A titration is a technique used to work out the concentration of an unknown solution of another solution. You simply add the known solution to a set volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use an indicator to signal the end of the reaction. You can calculate the concentration of an acid or an alkali by carrying out a titration experiment. In this video, we are going to look at how to carry out titrations. In the next video, we will then look at the calculations to go with the experiment. The apparatus needed for titrations looks like this. The pipette is used to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to a 0.05 cubic centimeter accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with the known solution and make sure it is leveled off at exactly 0. 4. Slowly add the solution from the burette to the unknown solution in the conical flask. 5. You may need to swirl the flask to mix or use a stir plate. 6. Stop adding when the reaction is complete or the endpoint is reached. This is where an indicator may help you because there would be an appropriate color change. 7. Record the final volume on the burette. This gives you the volume of the solution added. This volume is called the titer. 8. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titer. Depending on the indicator you use, the color change will be either gradual or sudden. If you are carrying out an acid-alkali titration, you may use universal indicator, which would give a gradual color change. Though this might not be ideal because of this gradual color change. Litmus gives a sudden color change. But there are other better indicators that are specialized for the acids and the alkalis in the titration. Sometimes the acid may be the known solution and the alkali unknown, and other times the alkali the known and the acid the unknown. So we have carried out the titration a few times and have a consistent value for the titer. What do we do next? Titration calculations! Now that you know how to carry out titrations, watch the second part of this video to see how to do titration calculations, to work out the actual concentration of the unknown solution. All you need to really remember is that titrations are used to work out the concentration of an unknown solution when you know the concentration of another solution.
All right, there's titration. Let's go through and figure out how to do titration calculations now. So here we go, titration calculations, back to the guided notes. And let's figure out how to analyze or figure out titration. So above, we talked about volumes, we talked about concentration. Now let's go through and figure out this titration formula. So open up the reference table. If we check out the reference table, let's scan through that again. It's been a little while since we've seen this. We're close to the end of the year, like a month left. We went through page 1 of the reference table. We're all done. We went through everything. You should be aware of everything on that. Page 2, we went through, done. Python ions and solubility guidelines, done. Page 3, solubility curves, you should be aware of how to interpret that. Same thing with page 4, vapor pressure of 4 liquids, done. Page 5, we went through reactions and activity series, done. Next page, we went through acids, we went through bases, we went through indicators. We did not go through table N. We'll do that for the last unit. There's 2 more units left. We have organic chemistry, which is next, and then the last one's going to be nuclear chemistry, which is going to be on table N. We'll go through that there. We went through table O a little bit. There's more things that we have to go through, like alpha, beta, gamma. We'll do that in the last unit. We have to also go through organic prefixes next unit. This is next unit, and so is table R, the next unit as well. But we did go through the periodic table. Hopefully you know something about that. Hopefully you know something about physical properties of elements. And last page of the reference table are the formulas. We went through density, done. We went through mole calculations, done. Percent air, done. Percent comp, done. ppm, molarity, combined gas laws, done. We went through heat, we went through temperature. The last formula that we have to analyze on the reference table is titration. The whole topic for today. Titration, there it is. What is it? It's the molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. So Ma is molarity of the acid. It says molarity of H plus ions. If you don't know what an acid is, it tells you right there. An acid's H plus ion. Va is volume of the acid. It says right there, volume of the acid. The acid, again, tells you in the reference table, if you ever forgot, an acid's going to be H plus ion. Second part of the equation, talking about the base. Molarity of the base times the volume of the base. Molarity of the base equals molarity of OH negative. Volume of the base, if you don't know what a base is, it tells you right there, a base is actually OH negative. This is a formula we will interpret right now in class. So let's go through that formula. Let's figure out how to use it, how to apply it. After we do that, the last page of the reference table is completed. We went through everything there. So titration formulas on the reference table. I'm going to copy this down. You could copy and paste from the reference table if you want to. I'm going to color code it as well. So here we go. It's going to be molarity of the acid, Ma, capital M, control, comma, A, molarity of the acid, times the volume of the acid, control, comma, equals molarity of the base times the volume of the base. Molarity of the base times the volume of the base. We will interpret this formula for majority of the class today. That's in the reference table. No surprises. MV equals MV. All acids, all bases. Ma. Ma is representing molarity of the acid. The unit for molarity, we saw earlier in the year, unit for molarity is M, molarity, concentration, capital M. VA is the volume of the acid. We should understand the unit for the volume. Volume of the acid. The unit for volume could be liters. It could be milliliters. It probably will be milliliters for this course or for this topic. We're talking about smaller volumes. Milliliters. Hey, we talked about that in Unit 1. Milliliters. King Henry died unexpectedly drinking chocolate milk. Pay attention to this class. You really do learn a lot of new material. MB is going to be molarity of the base. I like color coding still. MB is molarity of the base. Units of molarity as M, concentration. And last but not least, VB is the volume of the base. The volume could be in liters. Typically going to be in milliliters. You want the same exact units. The units do not correspond. If they're not matching up, you're going to have to convert one of them. When solving titration problems, the molarity of the acid and the base must be expressed the molarity of hydrogen ion, H+, and hydroxide ion, so acid or base. Let's try to solve an expression. Let's try to solve one question. We'll do it together. All right, here we go. Question number 1, example number 1. Next page, I'm gonna make this on the next page. Just scroll down. Question reads, what is the concentration of hydrochloric acid solution if 50 milliliters of a 0.25 molarity KOH are needed to neutralize 20 milliliters of HCl solution of an unknown concentration? A lot of stuff going on there. I would suggest highlighting it, figuring out what the heck you have, figuring out what they're asking you to solve for. We'll organize our data, and then we'll figure out an approach to solve for the information. So let's break it up again. What is the concentration of hydrochloric acid? Oh, that's my question. What is the concentration of hydrochloric acid? That's what we're looking for. I'm going to color code this. We know hydrochloric acid is an acid. We're looking for the concentration right there. What is the concentration of the acid? So concentration of the acid. If 50 milliliters, that's definitely important, of 0.25 molarity of KOH. Oh, let me start here. KOH is a base. OH is their hydroxide. We have a molarity of the base. So that's important. We have 50 milliliters. That's a volume. Or you're like, is that a volume for the acid or is that a volume for the base? Reread the question. What's the concentration of hydrochloric acid solution if 50 milliliters of 0.25 molarity of KOH? Oh, there's 50 milliliters of 0.25 KOH. So that's going to be relative to the base. Are needed to neutralize 20 milliliters of HCl, hydrochloric acid. So the volume of the acid is 20 milliliters of an unknown concentration. Hopefully you can figure out that those 4 pieces of information are important. All right, next up, I'm going to click on the cell below. I'm actually going to delete this cell. I'm going to delete that cell. I don't like the setup of that one. So I'm going to delete this cell below, hopefully. Let's see, delete row. And then I'm going to go below again. And this time I'm going to insert a different table. I'm going to go 2 by 2. So real quick, I'm just going to show you what I'm going to do. I'm going to show one column for my work or my known values. And then over here is going to be my work. So the reason why I change it is just so I can show you my values, my known values. And then over here is going to be my work. How the heck did I do that again? I deleted my row and then insert table. I went 2 by 1. 2 by 1. Then you could stretch that cell out. Just going to make your work a little bit more organized and neat. You don't have to. If you want to do the examples on a separate piece of paper, feel free to, but do not forget to upload the data. All right, the first column is going to be the known values. These are coming from the passage, the question, the known values. What do we have here? I'm just going to go right in order. What is the concentration of HCl, hydrochloric acid? So concentration is going to be molarity of the acid. MA, concentrations, molarity. We are looking for that. Molarity of the acid is what we're looking for. That's our question mark. Next piece of data we have 50 milliliters. Hopefully you know 50 milliliters is a volume. So below I'm putting volume of my base. I'll change the color in a second. Equals 50 milliliters. Definitely volume of the base. Next piece of information, we have 0.25 molarity. Next piece of information, it's a molarity, it's a concentration. Molarity of the base equals 0.250 M. That's a concentration. Last piece of information we have is 20 milliliters. Milliliters is a volume. So I'm just going to pair this up together with the other red font. It's a volume. Volume of what? Volume of the acid. 20.0 milliliters. All this information we got from the passage. The question, what's the concentration of HCl? Molarity of HCl we're looking for. We have 50 milliliters of KOH, volume of the base, 0.25 molarity of KOH, molarity of the base. And last but not least, we have a volume of the acid. What's up? Joey. Five 21. You're welcome. All right, so here we go. Let's figure out that formula. Let's figure out how to plug it in. I know you guys could probably do this without even me teaching it now. So I'm going to copy that formula. The one I have above. I'm going to copy it. Control C. I'm going to paste it below. Control V. So I'm taking that formula. I'm actually going to copy and paste it again one more time just so I have the color code system already in there. Now I'm going to plug in my information to left. If anybody wants anything repeated, they want to see something again, please let me know. Plug in your information. Molarity of the acid, we don't know. We're looking for that. I'm going to call that X. The volume of the acid is 20.0. Units, milliliters. Molarity of the base, 0.250 M. And last but not least, the volume of the base is equal to 50. All I did is I plugged the information from the known values into the formula. X times 20.0 milliliters equals 0.250 molarity times 50 milliliters. I think you know what to do next. Solve for x. So please solve for x. Please put the answer in the chat once you solve for the unknown. So please solve for x in the expression. Please let me know what you get for an answer. I do have calculators. If you want to use a calculator, help yourself. Use your phone calculator, I don't care. Please solve for x. At home, please put your answer in the chat once you derive an answer. Thank you. Thanks, guys. Please record your answer at home once you derive an answer. You agree, Todd? Did you get anything or no? All right. Did you get a number or no? What'd you get? Like 625. And so are a couple people at home as well. Let's check it out. Let's see if that's going to be the correct value. So solve for x. How do you do it? First thing you want to do is get x all by itself. X is upstairs. I'm not touching x. I want to get rid of the 20 to the left side. So how do you get rid of 20? You divide 20 by 20. 20 divided by 20 cancels out. What you do to one side, you do to the other side. So I divide by 20 to the left, divide by 20 to the right side. And I hope you all could solve for that expression right there. Throw it in the calculator. Solve for that expression. Let's do that. So in the calculator, I'm going to use my app. There's an app for that. So in the calculator, solve for the expression. A little off. We have 0.250. Multiply that by 50. I get 12.5. Take that number and divide it by 20. Take that, divide it by 20. It looks like an answer that several of us got in class. 0.625. 0.625 looks like a solid answer. So 0.625, it's going to be the concentration of the acid. 0.625. So solving for x, we have the concentration of the acid. X equals, or molarity of the acid equals 0.625 units are molarity. Science, you should always represent a number with a unit. If it has a unit, you should represent it with a unit, especially for physics. Molarity of the acid equals 0.625 molarity. This number is to the thousandths place. Your molarity here should be to the thousandths place as well. Does anybody have any questions on how we did titration? We neutralized. We took a volume of an acid. We took a volume of a base. We mixed them together. we had a known concentration, we solve for the unknown. Any questions on how to do that? All right, let's watch one more flick, last flick for the day. Look at that's a nice video. Nice image. What is titration?
What is a titration? A titration is a technique where a solution of a known concentration is used to determine the unknown concentration of a solution. Usually, the solution of known concentration or titrant is added from a burette to a known quantity of the analyte, the unknown solution, until the reaction is complete, which is indicated by the endpoint. The accuracy of the results of your titration will be a reflection of the care you took while performing it. When done carefully, titrations give very accurate, precise results. Here is a step-by-step procedure required for performing successful titrations. The burette has now been cleaned and prepared as shown in the previous videos. The meniscus is level with any graduation mark on the burette between 0 and 2 milliliters. The initial reading will be recorded, remembering to do it to 2 decimal places. The analyte solution is pipetted into the conical flask and then a few drops of the indicator is added. The conical flask is then placed under the burette. When performing the first titration, the solution is delivered at a rapid pace to get a rough idea what volume is needed to reach the endpoint. This is known as a rough titration, and it is not included in your final results as it is not accurate. However, you still need to record the final volume reading from the burette. The volume of solution delivered is determined by subtracting the final reading with the initial reading. The burette will then be refilled. Initial readings recorded and the solution in the conical flasks prepared in preparation for the next titration. The next titration will be done carefully to ensure that the endpoint is not missed using the volume recorded during the rough titration. The general procedure is to deliver approximately 3/4 of the volume of titrant recorded from the rough titration at a rapid pace and then add the titrant slowly until the endpoint. It is even possible to add a drop, swirl, add another drop, and so on until an endpoint is reached. When approaching the endpoint volume, a good habit is to wash the sides of the conical flask with distilled water from a wash bottle, as when swirling, the side of the conical flask will touch the tip and some of the titrant will stick to the walls of the flask. If there is a droplet hanging on the tip of the burette, wash the droplet into the flask using a wash bottle, especially when approaching the endpoint. Washing off the titrant will result in a more accurate and precise result. Once the endpoint is reached, the final reading is taken and the total volume of titrant delivered is determined by subtracting the final reading from the initial reading. Titrations are generally done in triplicate, so you will need to perform 2 more titrations. To get precise results, your volume of titrant delivered for the 3 non-rough titrations should be 0.1 milliliter difference between each titrant volume delivered. If this is not the case, additional titrations will be performed to get precise results. To better observe the color change of the indicator, a plain white piece of paper is placed under the conical flask. For right-handed individuals, the burette tap will be handled using your left hand, while the flask is swirled with the right hand. However, for left-handed individuals, the burette tap is handled with the right hand and the flask swirled using the left hand. In this case, the left-handed individuals will have to reverse the burette to accommodate their titrations. Here is the summarized procedure required for successful titration. Step 1.
Okay, I'm going to stop that video right there for titration.
If
Typically, we would have done a lab on titration, but today it's a little bit different what we're doing. So anyways, you know the basics of titration. If you take AP Chem, you'll definitely do a titration lab, as long as we're not virtual again. But you might do titration in college. Titration, you're taking an acid, you're taking a base, you're mixing them together to get known volumes and known concentrations. Let's try a second example for titration. We went through one, we got 0.625 molarity. Let's try the second example as well. So here we go, very similar to the last example. This is the last main portion of notes. Next time in class, we'll go through like the basics for review. For everything for unit number 9. All right, question number 2. What is the concentration of sulfuric acid solution if 50 milliliters of a 0.85 molarity KOH are needed to neutralize 120.0 milliliters of the H2SO4 solution of the unknown concentration? A lot going on there again. Figure out what you can relate with. What is the concentration of sulfuric acid solution? That's your question. What is the concentration of sulfuric acid solution? I'm going to highlight that. I'm going to make it red. Probably thought I was going to make it rain. Make it red. The solution is 50 milliliters. If 50 milliliters of 0.85 molar KOH are needed. You know OH is a base. It's potassium hydroxide. There's a molarity of the base. Oh, 50 milliliters of 0.85 molarity KOH. That is the molarity and the volume for the base. To neutralize 120 milliliters of H2SO4, you're like, oh no, what the heck is H2SO4? You have a base, you probably know it might be an acid, but if you're stuck, you can use a reference table, look at common acids, common bases, H2SO4, common acids, common bases. Oh, H2SO4 is sulfuric acid. So they gave you the name. They also give you the formula for sulfuric acid. H2SO4, definitely an acid. And that's all we have here. I'm going to do the same thing I did last time. I'm going to take this text box. I'm going to take this cell. I'm going to delete this row. I'm going to insert. So again, I'm just going to take this out, highlight it, right-click, delete row, and then I'm going to insert 2 cells side by side, 2 by 1. So right there, I'm going to insert table 2 by 1. I just like to keep my work organized. I like to be as accurate and precise as possible so you can follow along what I'm doing. Use this technique in physics when you take that next year. Use this technique in AP Chem, math class. The left column is going to be known concentration. And this is going to be the information from the passage. What did I get from the passage? So at the end of the year, when you have that post-test, it's going to be tough. You're not going to know directly. It's going to be a titration formula. You're going to have all the content through all the year, and you're going to have to figure out which formula to use. It's going to be a lot tougher. This technique helps it out so much. Concentration of sulfuric acid. So concentration is going to be the molarity of the acid. Molarity of the acid is unknown. Molarity of the acid we're looking for. Next piece of information is 50 milliliters. That's going to be a volume. Volume of what? Volume of the base. 50.0 milliliters. Next up, we have 0.85 molarity. That's a molarity. M and M, match them up together. Molarity of the base equals 0.85 m. Those are definitely both bases, I'll color code those blue. And last piece of information, we have 120 milliliters. That is a volume of the acid. So V of A, volume of the acid equals 120 milliliters. You should be able to organize this into your known values. Known, not concentration, known values. Once you have that, you can look at the last page of the reference table, and hopefully you'll know that it's going to be titration. Formula for titration, molarity of the acid times the volume of the acid equals molarity of the base times the volumes of the base. I'm going to copy and paste the formula above. I'm actually going to copy the first two lines there. Copy and paste it. And now we can plug in the information. We're looking for molarity of the acid again. It's not going to always be the molarity of the acid which we're looking for. We have a volume of 120. Molarity of the base is 0.85. And the volume of the base is 50. Please solve for the unknown. Solve for x. Try it out. The more you are engaged with class, if you try these examples out, the quicker class goes by. If you're sitting there dazing, you're not getting anything out of it. Clock's gonna go real slow. Please solve for x. Please put the answer in the chat once you derive an answer. Thank you. Good. 1 for 1. Please record your answer in the chat once you have an answer. Joe, once you get an answer, let me know what you get. Two for 2, thank you. If you need help, let me know. We'll do it together. All right. Gotcha. 3 for 3, thank you. .354. So 0.354. What's the units on that? Molarity. Good. So 0.354. Several of you guys already got that, or 0.35 you got. Your answer should be to the least precise measurement. In this situation, we have molarity is to the hundredth place. For the base, your answer should be to the hundredth place as well for the molarity of the acid. So that would have been fine, unless they said to the least precise measurement. Then in this situation, it would have been 0.35 molarity. Either way is fine. That's more of a rule for physics. All right, that is titration. You guys now know how to calculate titration formulas. Acid plus a base yields salt plus water. It's neutral. Volumes are going to be represented. Molarities are represented in the solutions too. All right, that is it for new notes for the packet. Tomorrow we'll wrap up the quick reference guide. We'll do that next time. But the rest of the class today, we're analyzing examples on this topic. So please go back to the home page, Google Classroom page, scroll on up. It says examples, Unit 9, Topic 5B, titration. Unit 9, Topic 5B, titration. There's like 5 questions here. It's going to take a little longer to do, but once we get through these, it'll give you time to work on the exit pass. I'll probably start off tomorrow's class giving you time to work on the exit pass on titration. You could do it tonight for homework if you want to, but I'm going to give you some time tomorrow to complete the exit pass. So here we go. This right here is going to be more for us to do together. And then the exit pass is for you to do on your own to assess, do you know how to interpret these questions? Examples, here we go. Unit 9, Topic 5B, titration. Let's go through them. The diagram picture shows NaOH being added to HCl. A few drops of phenolphthalein were added to the flask before the titration was started. The endpoint in the titration is reached when the solution in the flask appears to what color? Again, there's a stand, there's an Erlenmeyer flask, there's a burette. We have the base in the burette, we have the acid in the Erlenmeyer flask. Phenolphthalein's in there as well. Let's just check out phenolphthalein. Phenolphthalein is an indicator. Phenolphthalein is going to either turn colorless or pink. Colorless or pink. We watched 3 videos today. Colorless or pink. You're going to drop the base into the acid. Once it turns like a pink, then it's going to be the end of the titration. Equilibrium would be reached there. One of the best answers is going to be choice A. Next up, number 2. Titration question. It's going to take some time here. How many milliliters of 0.01 molarity of NaOH are required to exactly neutralize 20 milliliters of 0.020 molarity of HCl? Take about 3 minutes. Think about this. Figure out what the titration level is going to be, or the volume is going to be of this solution. I'm going to sit here quietly. I'm going to actually highlight some things as we give you some time. But you have 3 minutes to work on it. Once you have an answer, please put it in the chat. 3-minute timer. New York Giants, you're on the clock. It's not a bad idea to use scrap paper, folks. Please record your answer in the chat once you get the answer. Number 2, what's the best answer? Please record it in the chat. Thank you. All right. So anyways, please record your answer in the chat. I have some D's. I have some C's for responses. Here's the work. I have 20 molarity times 0.02. That's the volume of the, that is the molarity of the acid times the volume of the acid equals 0.01 molarity times X. We had to solve for X, get X alone. So here we go. Take out your calculator. Let's solve for this. We had to solve for the expression right here. Hopefully we get the same answer. Unless I mess something up here. Calculator. Come on up. Come on up. All right, in the calculator, plug it in. We have 20. Great. Sneak it over. 20. All right, 20 times 0.02 equals 0.4. Take that number and divide it by 0.01. 40. 40 is the correct answer for number 2. So number 2, the best answer would have been, would that work? Choice D. 2, the best answer is D. Does anybody have any questions on how we got that? Good? Mr. Abraham? All right. Number 3, same approach. Here we go. Let's try out number 3. Very similar question. How many milliliters of 0.6 molarity of H2SO4 are required to exactly neutralize 100 milliliters of 0.3 molarity of BaOH? Pretty BA, if you know what I mean. 3 minutes on the clock. Give it a shot. Again, number 3, 3 minutes on the clock. Please try it out. I will sit here quietly. I'll highlight the important parts of the question. Please solve for X. Please let me know what you have for an answer. Please put it in the chat. Thanks, Joe. Thanks, Nyla. Thanks, Jennifer. Thanks, Lena. Emin, what'd you get for that one? B. All right, everybody that responded, put B. Solving for that 0.3 times 100 equals a value divided by 0.6. Let's just check it really quick. 0.3 times 100 divided by 0.6. 0.3 times 100 divided by 0.6. 0.3 times 100 divided by 0.6. Here we go. Clear up my calculator. 0.3 times 100 equals 30 divided by 0.6. 50 we just got. 50 is the best answer for number 3. All right, number 3, best answer is going to be choice B. At this point, guys, I'm not going to do any more examples right now. Next class, we'll start off with examples 4 and 5. We'll go through those, and then I'll give you some time to work on the exit pass on titration. All right, guys, that's going to be it for today's class. Have a good day. Make good decisions. Be kind to one another. Stay safe. See you later. If you have any questions, feel free to hang out. That's it for today. See you later, guys. Enjoy titration.